Hey, welcome back to Coding at Home. Today we are not proposing a new game, but we are working with encodings. In particular, encodings allow us to transmit, store or process information. But what about drawings? Is it possible to find an encoding that can be used to transmit a drawing from a notebook to another? Or even better, it is possible to transmit a drawing from my mind to your notebooks. Okay, that's what we are trying to do today with Anna. Hi, Anna.
Hi.
To start with this encoding, let me first take a square sheet and to point out just 4 of the squares in it. And in order to allow you to see what I'm doing, let me take 4 big squares and first of all concentrate and focus on these ones. What we can do is to color them, and instead of coloring them in order to reuse the same 4 squares, I will put tiles on each of them. If I put a tile on a square, this means that this square is colored. Okay, if I don't put a tile, then I leave it empty, meaning that it is not colored. Okay, now what I want to do is to imagine that each square has a weight, and the first one has just weight 1. This means that if I color it, these 4 squares that are 3 empty and just 1 colored have weight 1. The second square has weight 2. So this means that if we put our tile on this square, then the weight of the 4 squares becomes 2. The third one has weight 4, meaning that in this case the overall weight will be 4. And what about the fourth one? The fourth one has weight 8, meaning that if I move to the left this tile, then the entire block becomes twice heavier than before. Okay, so weight 4, weight 8. And Anna, what about coloring these 4 squares in order to obtain an overall weight of 3?
I would put 1
Okay,
plus 2.
perfect. Okay, as you can see, weights sum up. So in this case, the overall weight becomes 3. And what about 5? How can you obtain 5?
Still 1
Okay.
plus 4.
Okay, and what about 7?
Okay. 1 plus 2 plus 4.
Very good. So as you can see, there are many different ways of coloring these 4 squares. And for each of them, for each configuration of the tiles, which means for each way of coloring them, we obtain a different weight. And we can try to figure out how many different weights we can obtain. And I prepared this in order to try to figure out which are all possible weights and the possible configurations associated with them. So let me put here a 0. So if we start from 0, how can you obtain weight 0?
Not coloring
Any square.
square.
Perfect.
Square.
Okay, so this means that this is already the appropriate configuration that provides 0. This is 1. So could you please color... Oh, sorry, let me just annotate the weights on top in order to make it clearer.
Okay.
Okay,
So
Yeah, exactly. And 2. Good. 3. Very good. 4. Okay. 5. Okay. 6. Not that easy. Very good. 7. And 8. You see, once the first squares are colored, if we need to add 1, we have to empty all of them and to color the one to the left, which was still empty. 9. 10. Almost done. 11. 12. You should look at her face. Oops. 13. Good. 14. And 15. So I have a question for Anna now. How many different configurations?
15 plus 1.
Oh, great. So 16. Okay, so there are 16 different ways of coloring these 4 squares. Okay, now let me please point out that we have associated numbers with configurations of colored squares. So right now, using this table, which is an encoding by the way, I can tell Anna to color these 4 blocks according to number 11, for instance.
Okay. 8 plus 2.
Okay, so there are
plus 1.
2 possible ways of solving this simple challenge. So the first one is by reasoning and finding the appropriate combination of these 4 numbers, the sum of which provides the number that I proposed, 11 in this case. The other way, simpler, is by looking at the table and finding the row associated with number 11, okay? And the result, of course, is the same. Now, let's try another one. So, for instance, number, I already asked. Okay, number 13.
Okay. So, 8.
Okay.
Plus 4. Plus 1.
Very good. Okay, there is something that I'd like to point out, which is the fact that the numbers that represent these possible configurations of colors are quite different if we look at the first 10 of them from 0 to 9 and the other ones, because going from 0 to 9 we need just 1 digit to represent the code associated with the coloring of the 4 blocks, while from 10 to 15 we need 2 digits. This is a kind of an asymmetry in our encoding that is not suitable for an encoding. It is much better to use always the same number of digits to represent similar things, like, for instance, in this case, the coloring of 4 squares. That's why, to the right, I write a different encoding. I use the same numbers from 0 to 9 But instead of using 10, I introduce a new symbol and I take a letter A instead of 10. Letter B instead of 11, C instead of 12, D instead of 13, E instead of 14, and F instead of 15. Right now, this new encoding is much better just because it associates just one digit to our configuration of the 4 squares. Okay? And now I can tell Anna, for instance, to color the 4 squares according to code F.
Okay.
Okay. Now we have an encoding. An encoding is nothing but something that we agreed to use. So it's our own decision to associate these codes with these configurations. But once we have done so, we can go back to our squared sheet and take any region of this sheet and consider it as composed of blocks of 4 squares each. And for each region, for each sub-region like this, we know how to represent the coloring of it. So for instance, if I ask Anna to color these 4 squares according to code A, how would you, Anna, color it? Okay, and then the next 4 squares according to number 11. Oh, sorry, B. I am not using the encoding that I just created. Okay, so the encoding that we are using is effective in allowing Anna to draw something based just on the code that I tell her. And since I'm using 16 different symbols, this encoding is called hexadecimal. Okay, so that's why this lesson is called Hexadecimal Drawings. But let me see if it is really possible to dictate a drawing. So I'm trying to dictate an entire drawing to Anna right now, and I report the weights on top, because as you can see, this is an 8 by 8 region of our squared sheet. And since I consider it composed of sub-regions of 4 squares each, I report the weights on top of the left part and of the right half of the image. And I start dictating to Anna the drawing starting from the top left, meaning that the first code that I will dictate will represent the way of coloring this first half of the first row. Then I will tell you how to color the second half of the first row and so on. Okay? Are you ready? Good. Instead of just dictating it, I will also write down the code of the associated with the 4 squares that you have to fill in. Okay? So the first one is very simple because it's 0. Okay. Done?
Done.
Good. The second one is 6. Here it is.
Okay.
Okay. Then we have 6, second row, first half. And we have F to the right. Here we have F again. Another F. F again. F again. Yet another F. And now this is E. While this is 7. Very good. And this is C. Three. 8. Good. 1. And 0.
Done.
Done. What is this?
A heart?
A heart. Very good. So what happened is that I dictated something that was a drawing, and Anna were able to just draw it, was able just to draw it down without having seen any representation of this art, just because we agreed on the encoding that we were using. This is exactly the same technique that computers use in order to transmit images from a computer to another. For instance, the images that you are receiving are more or less encoding like this. And this is something that is quite magic, because if you did the same, basically the same work that Anna did by drawing this means that the same art also appeared in your notebooks. And this is very interesting because I don't know where you are, but you are for sure very far from Urbino, that is the place where I am right now. Okay? So let's try to draw something else, but this time I want to ask Anna to draw it in order to allow you to figure out what we are actually dictating. Okay? So instead of drawing, Anna, could you please annotate the code that I will dictate to the left and to the right of each row? Okay?
Okay.
So the first code will be annotated to the left, and the second one to the right of each row.
Okay.
Okay, so first row is 3 to the left, and C to the right. Then 6, both to the left and to the right, so 6, 6. Okay, now it's C to the left and 3 to the right. Then there is another C to the left and 0 to the right. C, 0 again. Okay, C, 3. Six, 6. 3, C. 3, C. Good. Okay. Now, this is something that represents another drawing, and I'm just wondering if you can figure out what the drawing is without actually drawing it. This is more challenging because you can even refer to the table to try to figure out what it represents. And I made it quite easy to recognize just to allow you to try to think at it without writing anything, without drawing anything. And to conclude, I would like to ask Anna to invent another drawing and to dictate it without even annotating the codes. So this will be just pronounced by Anna. So this is like a true dictate, and I'm very curious to see if you can figure out just by thinking in your mind what Anna is trying to dictate. So let's start to the left, to the top left. Could you please pass me the scissors? Thank you. Because I'd like to, just to make it a little bit easier, I'd like at least to point out what portion of the drawing you are referring to. So let me take this out in order not to confuse. Okay. So first row, left.
F.
Right.
F.
Second row.
6. 1.
Third row.
6. 4.
Fourth row.
7. C.
Fifth row.
6. 4.
Okay. Row 6.
6. 0.
Okay. 7.
6. 0.
Last row.
F. 0.
Okay. Can you please try to repeat the entire sequence? So all the letters and numbers that you said, if you can repeat them in sequence.
Okay. So F. 6. 1. 6. 4. 7. C. 6. 4. 6. 0. 6. 0. F. 0.
Okay, I'm very curious to know if you can figure out what the drawing that Anna dictated represents. Needless to say, you can also try to make the drawing or annotate the sequence, but what is very, very nice is the fact that the 16 symbols so the 16 digits that she pronounced represent the drawing, exactly as the ones that we used before, like these ones, represented a heart. So in order to dictate a heart, I just said 0, 6, 6, F, 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 E, 7, C, 3, 8, 1, 0. And this is a heart. Not just a generic heart, but this specific heart. Okay? So that's hexadecimal drawing, and it is a way of using encodings to dictate drawings. Bye bye.
Bye bye.
Bye bye, Anna. And by the way, here is Anna.
Bye.
Bye bye. See you next time.